Welcome everyone to this explainer. You know, to survive in the desert, you really have to master the art of biological defiance. I mean, we're talking about taking survival and turning it into an absolute art form. Every single leaf, stem, and root out there in these arid landscapes, it's a highly specialized mechanism engineered to beat literally impossible odds. Today, we're going to dive into a world where organisms have taken the absolute harshest conditions you can imagine and just transformed survival into an exact science.
Okay, let's dive into this. Because, the popular perception of the desert as just this lifeless, endless, static wasteland, well, it couldn't be further from the truth. In reality, the desert operates on a highly dynamic, incredibly high-stakes timetable. Hiding right beneath the surface is this entire world of extraordinary biological adaptation. It's basically functioning as an extreme, fast-paced testing ground for life.
And when we say extreme, we really mean it. Imagine a daytime high soaring above 50 degrees Celsius. That kind of heat literally bakes the soil and violently drains moisture from absolutely everything it touches. But the real stress test here isn't just the heat, it's the thermal shock. Because when the sun drops, temperatures can actually plummet right down to near freezing. So these plants aren't just enduring a heat wave, they are surviving massive, wild thermal fluctuations every single day.
But honestly, the ultimate hurdle here isn't the scorching heat or the freezing nights. It's the catastrophic lack of water. We're talking less than 250 millimeters of rain for the entire year. To put that into perspective, that's barely enough to fill a large coffee cup in some places. And whether the landscape is made of rocky gravel or it's a freezing, wind-swept plain, the defining challenge isn't the sand, it's the severe, chronic mathematics of that water scarcity.
Now, think about the three essentials of plant survival: water, sunlight, and nutrients. In most normal ecosystems, these things exist in a pretty comfortable balance. But out in the desert, this equation is entirely warped. The sunlight is basically weaponized against you. The nutrients are locked away in dry, super porous soil. And water? Well, water is the ultimate bottleneck. Solving this severe resource imbalance is absolutely crucial. It's the literal difference between life and death out there.
So, how do they do it? Well, it requires some profound microsolutions. Take succulents, for example. They act as these incredible living reservoirs. During those really chaotic, fleeting rainstorms, they undergo this rapid hydraulic expansion. Basically, they swell their tissues up to hoard enough moisture to sustain them through months or even years of severe drought. It's not just for looks. It is high-capacity water storage completely disguised as a plant.
And this brilliantly illustrates how the iconic cactus has engineered literally every inch of its body for ultimate water conservation. I mean, look at its anatomy. It's a true masterclass in defensive engineering. They've traded leaves for spines, which drastically reduces the surface area for water loss and, as a bonus, deters thirsty animals. Then you've got this thick, waxy surface operating like a biological hermetic seal to lock moisture in, while the green stems take over the entire job of photosynthesis. It's just genius.
And underground, the hidden architectural strategies are just as radical. Plants have these diverse ways to find water. The Saguaro cactus, for example, deploys a massive but extremely shallow root network to instantly capture surface condensation the literal second it hits the dirt, letting them stand as silent guardians for over 150 years. On the flip side, the mesquite tree drives its roots incredibly deep into the earth to tap hidden groundwater reserves far below. And then you have the acacia tree, using deep taproots to sustain itself so it can provide vital shade and shelter above ground.
But okay, what's truly staggering to me is CAM photosynthesis. This is a high-tech cellular solution to extreme heat that represents millions of years of evolutionary refinement. Basically, the plant completely changes its breathing schedule. To stop themselves from dehydrating during the day, these plants keep their pores tightly locked under the blazing sun. They only open them up to absorb carbon dioxide at night when the temperatures drop. It's mind-blowing that they do this right at the cellular level.
And then we reach the absolute climax of the desert life cycle. When that super rare rain finally arrives, the entire landscape just erupts. Dormant seeds suddenly awaken. A totally desolate terrain will, almost overnight, explode into spectacular high-energy life. These seeds patiently sit there, sensing their environment, and the very moment that moisture hits, boom, they violently spring into action.
This kicks off the ephemeral bloom cycle, which is basically a frantic, high-speed race against the returning sun. The moment conditions align, they rapid-fire through 3 steps. They germinate rapidly, bloom quickly, and produce seeds. Bam, bam, bam. They capitalize on this incredibly brief window of moisture, rushing through their entire life cycle in a matter of days just to secure the next generation before the inevitable drought comes back.
Pulling back to the macro view for a second, it's clear these plants don't survive alone. They are the literal foundation of the desert ecosystem. They provide the critical infrastructure for everything else out there. Birds nest right among the thorny cactus branches. Insects totally rely on those rapid ephemeral flowers for pollen. Small mammals feed on the rare seeds, and reptiles seek shelter beneath the shrubs. The quiet determination of these plants is the bedrock for an intensely interconnected web of wildlife.
Now, what's really interesting about this slide is how it bridges our ancient past with our future. Humanity has literally always relied on this deep resilience. Historically, desert plants were lifelines, offering dates for vital nourishment and things like aloe for medicine to sustain entire civilizations. But today, they are biological blueprints. Scientists are urgently studying these exact survival mechanisms to inspire resilient agriculture and new climate technologies for our rapidly warming world.
Yet there's a really profound paradox here. Despite all their extreme evolutionary toughness, these deserts are remarkably vulnerable to unnatural human-driven speed. Things like urban expansion, aggressive mining, overgrazing, habitat destruction, and rapid climate shifts completely disrupt environments that took centuries to form. Think about it. A cactus that easily survives 50-degree heat is actually incredibly fragile against a bulldozer, and it can take decades for these slow-growing species to fully recover.
Ultimately, I think the philosophical lesson here is just profound. Their success is not built on abundance. It is built on adaptation, flexibility, and resilience. These silent desert guardians thrive because they don't rely on resources just being handed to them, They succeed because they adapt perfectly to exactly what they have.
So that leaves us with a pretty massive question. In an increasingly unpredictable climate, what can humanity learn from the quiet resilience and flexibility of desert plants? The ultimate blueprints for our own climate survival and technological advancement might just be waiting for us right now, quietly growing in the harshest places on Earth. It really makes you rethink what survival looks like, doesn't it? Thank you so much for joining me for this explainer.